So first of all, thanks for having us here. Excited to be here. I went to the first one of these about 6 years ago, and I think it's a really great event. So I'd like to introduce Kristen Brown. So Kristen is from Exelon, which is the parent of ComEd and a number of other U.S. utilities, and she was formerly with ARPA-E. Kristen? And David Martin from PowerLedger. So David is the managing director and co-founder of PowerLedger, which is a leading blockchain energy trading platform based in Australia. So between Kristen and Dave, I think we've got the perspective of a traditional kind of conservative utility industry, although Kristen is not either of those things. And David, who's been working for quite a while now on developing and implementing new models using blockchain. So before we get started, just a question. How many of you would say that you know what blockchain is? Yeah, okay. How many of you own cryptocurrencies? Okay. Actually, that's a good number.
Their work is done.
So one of the difficulties that I found, and I've done a few of these classes now or talks, is trying to explain something that is actually a fairly technical topic in ways that people can understand it. So what is blockchain? And why should you care about it? So blockchain got its start with Bitcoin quite a number of years ago, I think 10, 11 years, something like that. And that's probably what many people associate with blockchain. But the underlying technology has really grown in leaps and bounds, and really an explosion of development and applications of those. So one of the key things that makes blockchain unique is the way it combines other technologies that prior to this were basically separate and had to be layered in on top of each other from multiple vendors and trying to stitch the data together. So at its root, blockchain is a network. So it's a peer-to-peer network of nodes that are connected and that know about each other. The second part is what you may have heard about a ledger, or you could also look at it as a database. So it's a store of information. One of the key things is once that information is stored into a block, it can't be changed. The next part is the cryptography layer, which inherently adds security to each transaction. And then consensus mechanisms is how do you validate a new block that gets added. And then something that's really quite unique is the ability to add validity rules, which are generally in the form of smart contracts. So you can actually have a transaction that is essentially self-validating. So there's different flavors of blockchain. So Bitcoin is what we would view as the first box there, which is permissionless, public shared. And one of the things I'd like to kind of get out of the way right now is around energy consumption. So Bitcoin has a bad reputation of being a power hog. So the way new blocks are admitted to the Bitcoin chain is through a process called mining. And I'm not going to get into detail on what that is, but it's extremely energy consuming. So I think the last stats I saw were that basically Bitcoin to run the network is the equivalent of the power consumption of Ireland. So we don't want that. Being conservationists and promoting clean energy, that's not something we want to support. And the good news is that the technologies that have evolved in the last few years get away from that mechanism of validation and basically are no more energy intensive than any other form of IT transaction. So what problems are addressed? And why is this something of value? So trust is the first part. So it eliminates the need for intermediaries between transaction parties. So if you think PayPal, if I wanted to send a payment to Kristen, I could do that on PayPal, and PayPal would take a cut, and it would have to go through their system in order to get to her. With a blockchain transaction, there's basically no intermediary because all the rules are contained within the transaction itself. It's essentially self-validating. Security is another part. So, everybody's concerned about cybersecurity and privacy. So there's a lot of mechanisms within blockchain, depending on how you set it up, that ensures that security is really first and foremost. Another factor is IT infrastructure overhead. So I come from an IT architecture background, so I have a pretty good understanding of how this impacts some of that if you get it to the point where it's really driving a lot of activity. So you don't need multiple copies of the same data, and there's reduction and redundancies as well. And then again, one of the key things that makes this really quite interesting is the ability to include smart contracts, which basically allow you to enable logic in every transaction. So that's, if you think about all these things put together, that's what blockchain is. And it is a unique kind of construct that we haven't had before. There's been a lot of hype and a lot of, I would guess, say misinformation, and a lot of news that is not necessarily favorable, but the underlying technology is still very, very interesting. So what I'd like to do is there's many potential use cases for blockchain, from financial transactions to public record management, but today we're focused on clean energy. So what I'd like to do is ask Kristen and Dave to walk us through some of the applications that they see for energy management that will really help move the needle in achieving a carbon neutral future. So we've got a few slides, and we'll get through those, and then we'll have some more interactive discussion, but I think the slides can help us. Kristen?
Yeah, super. So happy to be here, really engaging couple days. Just a little bit of background in addition to what Rick said. So I sit within Exelon Utilities, so it's the regulated arm of Exelon Corporation, and we own ComEd in Chicago, Pepco in DC, PECO in Philadelphia, and then Baltimore Gas and Electric. That's 10 million customers total in our fleet of regulated utilities. Again, we're just a poles and wires company, so all of our utilities don't own retail, it's competitive retail markets, and we don't own generation. Within that business, I sit in the strategy and policy team doing innovation and partnerships work, which is what's led me to the wonderful technology of blockchain. And as part of that, I'm part of a larger Grid Chain Labs organization whose goals are outlined below, but really what it was about was understanding how does blockchain fit into the business, both from the regulated side in our distribution utilities and also on the unregulated and competitive side of the business. So we touch topics all the way from REC trading, so renewable energy credit generation, tracking and trading, doing some work right now in exploring collaborations with PJM, who's our transmission operator, and tracking RECs created from the fleet of generation sources in that territory, all the way down to materials traceability and supply chain management within our specific utilities, thinking about both the gas networks and some of the materials that we need to procure within our businesses. If you go to the next slide, Rick. The use case that I've spent most of my time on, though, isn't about REC trading necessarily, and it's certainly not supply chain management. Where we came at it within ComEd service territory was really a mindset of driving economic development within our communities and trying to think around how can we create local markets of value and how can we put money into certain products and services that really struggle to obtain support and obtain financing. So we settled on energy efficiency as something I'm sure most people, if not everyone, is well aware of as necessary to meet our climate goals. And what we decided to do was to create a carbon offset market around energy efficiency to ideally allow large corporations who are looking for ways beyond RECs to offset their own emissions as a way additionally to put in financing into real projects, meaning energy efficiency upgrades and helping support local communities. So for instance, if you're a Fortune 100 and want to support, say, churches or schools via energy efficiency methods and then capture the carbon credits from that, that's what our project is aimed to help support. We decided to build it on blockchain to overcome a couple of specific challenges. One is the reporting and tracking and retirement of carbon offsets in general, and to alleviate some of the cost required to go through the verification validation process. But then additionally to help track the actual energy efficiency process itself. This is something we'll get into this discussion a bit later, but in a highly regulated industry where you need a lot of eyes on the processes that happen, with energy efficiency, the customer needs to know, the regulator needs to know, the validator needs to know, the installer needs to know, the utilities need to know, and reporting out on that is lengthy and it's expensive. A blockchain-based system and that distributed architecture that Rick talked about, we saw as a really key use case. So that's what a lot of my time at Exelon has been focused on, is how do we design and build this system, both to enable the carbon market itself, but then also to enable a much more seamless transition of all this information.
Dave.
So, yeah, as Rick said, I'm from Australia, from Western Australia actually, so it's about as far away from here as you can get. And we have, I guess in that space, the benefit of getting a bit of an insight into the future for energy systems, because it's crept up on us a bit sooner than it has done for most of the rest of the world. So we have three things in West Australia: lots of sunshine, really expensive grid supplied energy, and a really competitive and low cost solar PV market. And so now in Perth we have more than 1 in 4 households with distributed solar. In other parts of Australia, South Australia, it's a bit better than 1 in 3, in Queensland at 1 in 3. Some of our suburbs run backwards when it's a sunny day, the electricity system run backwards. So we have a real challenge around the adoption of distributed renewables into our system. And because of the way networks are regulated, the more consumers who step off grid or take most of their consumption of energy away from the grid, the more the cost of running the grid falls to consumers who can't afford it. So socially and financially marginalised members of the small business community for whom PV and storage isn't right now, those guys end up paying because everybody else is getting off the grid. And so we started to look at the challenge of the changing face of the energy system and say, how do we change the market and the regulatory framework to reflect the new physical reality of the energy system, where transactions aren't just linear anymore. We don't just buy energy from a power station 400 kilometres away and watch it travel through transmission and distribution networks until it gets to our house. We're buying energy off our neighbours. We might be selling it to our neighbours. We might be doing both in different market intervals. So how do you create a platform that reflects the physical nature of the system? And we realised if we were going to stop people from getting off the grid, we needed to create an environment where they could benefit from staying connected. And the only way we could do that was to turn the grid into a trading platform. And the only technology we could see that allowed us to deal with the complexity of the transactions that are happening in the marketplace at the moment is blockchain. So as that slide there kind of demonstrates, our platform reads all the meters all the time. And so when we can see energies being generated at Kristen's house and being consumed at Rick's place next door, we can tie a financial transaction to that physical transaction. If we can record in an immutable record like the blockchain all of the physical components of an energy transaction, who generated it, where, when, at what price, through what kind of supply mechanism, and then who consumed it at what price, and how did the energy get there. If we can record all of those physical components into a physical transaction, then we could tie a financial transaction to it. So we could get real-time reconciliation and settlement for the production and consumption of renewable energy. We can encourage people to stay connected to the grid. We can encourage them to install more PV than they just need for themselves because they sell it to their neighbours or to the school down the road or the rec centre down the road. And so we could create an economy that delivered low-cost, low-carbon and resilient energy supplies. because I said my slides backwards. So that's the system we have now. We don't have this linear system anymore. We have a system that is far more multilateral and with a much more complex kind of consumer transactions.
You got one more.
Oh, one more. Okay, picks 3. So this is an image of our major project that we're running in Thailand. So I should say, Power Ledger started in Perth in May 2016. And we ran a number of trials in Australia before we got picked up and dropped in New Zealand to demonstrate how we could use our platform to reconcile energy transactions in the New Zealand wholesale market in 30 minutes rather than 60 or 90 days like it happens now. From there, we went to Thailand. And so in Thailand, in the middle of Bangkok, one of the most energy-hungry cities in the world, we have a renewable microgrid where consumers can confidently install solar, know that if they have an excess of energy, they can take that energy and sell it to their neighbours, and they can use that system to create a resilient, low-cost, low-carbon energy system in the middle of Bangkok, with all of the financial transactions happening in real time. So we reduce the risk of market participation, we reduce the risk of revenue collection, the risk of people not paying their bill. We can actually get a very low-cost energy system, even in a city as energy-intensive as Bangkok.
Thanks, Dave. Okay, so let's kind of switch gears and talk a little bit about some of the challenges and perhaps some of the solutions that you guys see. So let's first start with regulatory, because I think that's key, and I would say there's actually 2 elephants in the room here. So the first is the SEC and other similar agencies in other countries and their treatment of blockchain and more, I guess, beyond, really not blockchain, it's really the cryptocurrencies and the activities around those, so initial coin offerings and exchanges as well. So in the last month, the SEC charged that 3 blockchain startups in the US failed to register their ICOs as securities and froze their assets. So one of them has gone to court and they've had that reversed, but the other 2 are still outstanding. The second elephant is really the regulatory framework that exists in most parts of the world and are more restrictive in a lot of areas than they are in others. So I think both of these contribute to making utilities and their partners nervous, at least in adoption. So what do you guys see as the real issues in this, and how do we address them?
I think the real challenge is we've got a new technology being deployed into a very mature regulatory framework or set of regulatory frameworks that just haven't kept pace with what the technology can deliver. So what the SEC's done in freezing a couple of those ICOs, good on them, because we need to bring more confidence and comfort and security into what could be a really good investment opportunity for a range of retail investors if it's done properly. So where it hasn't been done properly, where it hasn't been done in a way that complies with the intent of regulation, even if that regulation doesn't really contemplate how we do it with an ICO, then I think that's great because it builds investor confidence. In Australia, so the ASIC is our version of the SEC, we didn't have clear guidelines around an ICO either, but we did have really clear guidelines around financial services products and clear guidelines around IPOs. So we took the view that if we're going to comply in a future sense, if we're going to bring confidence into the industry, then we should impose a whole lot of obligations on ourselves. So we took the view that we would do it through our corporation, not through some kind of digital foundation. We complied to the extent we could with notifications and disclaimers and all those sorts of things. We geo-blocked US citizens from participating in our ICO. And so we took as many steps as we could to try and comply with what existed in the existing reg framework without knowing that we can't comply with it at all. But I think the clearer the rules become, the more these sorts of prosecutions and then arguments against prosecutions take place, the better defined the framework will become. And it'll be a lot cleaner, a lot more confident space for a lot of people to invest in. But then there's the energy regulations as well.
Yeah, so the energy regulation, and taking a step aside from the SEC, because that's not the regulation that we're concerned about as a regulated entity, a lot of it is it's uncertainty on how, as a utility, we pay way for a distributed system. So a lot of what blockchain does is it enables distributed decision-making and it's distributed governance, which in a lot of instances can mean distributed ownership. So when you think around distributed ownership under the current models, there's benefit there to help spread the value, especially in smart cities, given that one institution typically can't or might not want to take on the financial burden. There's a benefit there, but there's also a challenge there in determining how that cost is shared. When Dave was talking about the financial transaction aspect of the work that he's doing on peer-to-peer, there's a number of financial regulations that are challenging in understanding how do you actually get money on and off of a blockchain while maintaining a true stable currency, given some of the concerns around the volatility of tokens or what's now embodied as cryptocurrencies in a lot of ways. I think with the energy industry, the regulation we've seen the UK do this is there's a lot of talk now around setting forward regulatory sandboxes. How do you enable a consumer to sell energy to a peer without being a retail provider or a registered retail provider? That's one of the most challenging regulations that exists in a lot of the competitive markets right now that the states haven't directly addressed, but we see other countries starting to address. I think for us, what we've done is we've tried to have an open and education-oriented dialogue with our state regulators to help them understand the potential for the technology and both what it is and what it is not. And that helps them understand how it can be used both as a record-keeping mechanism, but then also for some of these more complicated financial transactions.
Yeah, I think that's right. I think the point to add to that, though, is the regulations they're prescriptive and they are a constraint on doing peer-to-peer trading in the way that we just described it, so my house to your house and back. But it doesn't mean it's got to stop us. So we've developed or deployed our trading platform with American Power Networks on the East Coast in Pennsylvania, where they're using the blockchain to sell energy that they are generating on their building and carport roofs to some customers of theirs. So they're an energy aggregator reseller. So they've already got access to a network, they've got all of the right licenses and all the rest of it, but they're using our platform to get instantaneous settlement for energy that they're selling from their roof to their neighbours in the same street. And so there's absolutely an important role for dialogue and conversation and testing these things, but there's also a really important role for action in this space. If we're really going to get the benefit of distributed renewables, which means shared ownership of distributed assets, more renewables, lower carbon and lower cost, then we've just got to start taking action and let the regulatory framework catch up in many respects. So let's comply with the intent of the regulations while we demonstrate how these things can actually be deployed and regulations can catch up with how they do it properly.
So one of the other things, and Dave, we talked about this earlier today, is kind of concerns over a lack of standards. So to a large extent, I kind of view this space right now as kind of the wild, wild west. So there's new applications, new technologies, new blockchains popping up all over the place. And they're not necessarily compatible. In fact, most of them are not compatible. What do you guys think as far as, and I've been in standards organizations, driving standards development, and it's not an easy thing to do. So where do you guys see the standards coming in and when?
I see standards being deployed on the back of successful deployments of the technology. So we didn't sit around in a room and decide whether we wanted VHS or beta. The kind of VHS just won. And so I think the same thing will sort of happen. In Australia, we've got the CSIRO, a bunch of legal firms, the Australian government working to sit down and go, well, what is the Australian blockchain going to look like? Okay, let's just boil the ocean for a while. Meanwhile, we'll deploy the thing and we'll figure out what the applications, where the application value is, and come back and build standards on the basis of successful deployment.
Yeah, I think what's exciting right now, and not to belabor too many of the challenges, because I think we're really here to talk about a number of the opportunities and what's exciting about this space. What's exciting is how new it is. Yeah. And I think we're all trying to figure out what is the balance in ensuring interoperability and connection between a number of new technology providers without constraining the market growth. And so there are a number of startup companies that are working on interoperability we're part of a large international consortium called the Energy Web Foundation, and they have a product called Polkadot that's about connecting different blockchains. But where we really see us having a voice and where we're really hoping that other corporations, other cities, other communities will join in, is talking about what are their needs, what data information is important, what types of security measures are important, what standards in data are important, so the companies and the vendors can build that into their offerings and the market moves towards a standard rather than necessarily having a top-down approach to standardization. That's to an extent why we got into the game so early, was to help be a leader in driving that conversation.
Cool. So before we close, I'd like to kind of bring it back to the spirit of the summit, and I guess kind of two questions. So what do you see as key areas where energy blockchain can help cities and communities move more towards their objectives of a carbon neutral future? And then as part of that, what recommendations would you have for agencies that are looking to start to kind of dip their toe in the water? How would they get started with a pilot? What would be a good approach, and what is the right, how do you find the right use case?
Well, there's about 800 consulting firms who I'm sure would love to help anyone in this room think through the right use case, and we certainly worked with a couple. But to me, and I say this a lot when I speak, is blockchain has really become this proxy for business model innovation. And there are instances in which blockchain is necessary, and there are instances in which it's not. But what it's really forcing people to do is think about new business model creation, new value creation, and new ways of reaching individuals and empowering individuals. So where I see it in the energy space, and I think dovetailing energies in with smart cities, is a lot of work around digital identity, talking about keeping track of building stocks, so giving buildings unique IDs instead of just having the meter or the land plot having IDs. That's extremely important for permitting. And I think there's a lot of work that's being done right now in thinking around, especially in buildings and energy, how do we link building information, consumption information, kilowatt hour information up through the utility and into other types, link that with other types of solutions and services. The challenge is that with a lot of blockchain projects, that requires a lot of consortium building and a lot of different partners getting on board with a shared architecture, which is, as most people I'm sure are very well experienced with, not an easy thing to do to build consensus around multiple partners. So when I think about the first steps that are necessary, and especially from my own experiences starting a blockchain project within my company, it's really about first identifying the partners you would want to engage with and understand the problem you're trying to solve before going down the path of saying, this is the blockchain architecture that I want to use, because you're almost putting the cart before the horse in that sense and trying to develop out an architecture before having consensus around the problem. So think about who it is you're trying to engage and what information you want to be shared and who's deriving value from that to determine how that information can be put on top of a standardized architecture that provides some more transparency into the system.
I think Kirsten's absolutely right. You need to understand what your problem is. And so for us, the most exciting thing about blockchain is it gives us an opportunity to look at an industry we've looked at the same way for the last 70 years, but which doesn't make sense to look at it that way anymore. So bringing it back to energy and sustainability, the biggest challenge we face in energy at the moment isn't a technology one, it's a cognitive one. We have to rethink how this system hangs together. So forever we had this view that energy was generated over there and pushed over there by big spinning machines, and that's the only way we could maintain security and stability in the system. Well, that's not the case anymore. Our regulatory framework assumes it's the case, our market framework assumes it's the case, the legislative frameworks assume that's the case, but the reality is really, really different. So we now have an opportunity to look at our systems as dynamic, interconnected, distributed systems, in which case we don't need big spinning machines. We can manage power system frequency and quality through storage. We can achieve a greater penetration of renewables than if we just managed it from a top-down approach. So in the events we're running out of time, but blockchain gives us the ability to do that. It gives us the ability to make sure we can share investment and we can share the return of those investments, and we can encourage communities themselves to be more invested in where their energy comes from and where the value creation goes back to.
Well, thank you very much, Kristen and Dave. Really appreciate the opportunity to speak here. What I really like about this event is the diversity of people, locations, and functions. So, and smart cities, I think, is a great kind of focus to bring that together. So, appreciate your time.